A critical part of meeting net zero is decarbonising our power networks. This means replacing fossil fuel power stations with increasing amounts of renewable energy generation. We are some way through this process, but it's not without its challenges and complications. Energy being taken from the network at any moment in time must also be met with energy being generated. This is called balancing the system, and if we don't maintain this balance, the system crashes very quickly, causing blackouts like the ones we saw in August 2019. Currently, balancing the system with coal or gas is easy. You simply burn more or burn less, but controlling renewable energy is not so simple. Consequently, to balance supply and demand, it's important that we can store that energy when supply outstrips demand, or discharge that energy when demand outstrips supply. This is called flexibility, and it's needed at a national and local level. Over the last 4 years, we've been testing flexibility in Cornwall as part of the largest trial of its type in the UK. Our model of the UK electricity system demonstrates how we need to move towards net zero. We've used water to represent energy, the pump represents generators providing energy, and the drain valves represent electrical loads. If the system is in balance, then the water pressure keeps the level between these upper and lower limits. This is a healthy system. If the loads increase or decrease, or if the renewable generation increases or decreases, the system operator must use flexibility actions to maintain balance. Let's see what happens when it gets windier. Now the system is becoming unhealthy and something needs to be done. To counterbalance this increase in wind generation, we can turn up the freezers at this ice-making plant and make more ice, or make it earlier than planned. For using energy when there is lots being generated, the ice plant receives a payment from the system operator. This is called demand-side response, or DSR. Alternatively, we might send energy into battery storage or export it to another country. If, on the other hand, the demand for energy suddenly increases, we have the opposite problem. We may now see businesses being paid to use less energy, and we might need to use some energy from the battery.